It's 100 years this year since the radioactivity section was set up. And it was set up because radium was just starting to become an item that was of interest. And so our whole history goes back to ionizing radiation measurements with radium. For the first half of the radioactivity lifetime, the lifetime of the unit, we've only measured radium. And then, of course, in the 1950s, we had all the nuclear power program, and we had all the nuclear reactors. And, of course, all of a sudden, there were hundreds, if not thousands, of radioisotopes to be measured. And when I joined the lab, they just started doing counting. And it was a fortunate time because it was still thermionic equipment. Transistors were just coming in. We did the counting on thermionic equipment, which had a half-life then of a mean time between failure of less than a week.
That's right.
So it really was quite... And we had, I recall, we had 3 nice young ladies who wrote the numbers down, because the numbers had been written down that you saw on the came up in the neon lights. No recording, no computers, nothing of the sort. And then they sat down and did hand calculations. So they had these hand calculators that they cranked away.
Oh, yes.
And it was clear that it's clear that we're not going to measure these hundreds of different nuclides with that sort of system.
That was before computers, actually.
Oh, yes, it was before computers.
Before computers. We had just used adding machines and things like that, basically.
We made automatic means of putting sources in so that we could count day and night. And we hooked it all up to one of the first mini-computers that was around. I think it was the first mini-computer in the lab.
It was.
Yes. We set ourselves the target of never writing a number down. We put the sources in, the equipment would count it, the computer would do the calculations. It was all connected together. 4K of memory of 12 bits width. And that was it. Yes. And yet it controlled all our counting equipment.
You could spend hours. A lot of people used to work into the evenings, no problem. Hours weren't a problem. We often used to work until midnight at night. To keep the experiment going.
I was very pleased that I came here because the radioactivity measurements group in this country was the world leader. I think.
Pleased to hear you say that.
Oh, yes, definitely. This was recognised at the time. And I came in to the lab and just sat in the library all Saturday, reading through the literature to see if anyone else had this idea. And it's one rather obscure Hungarian paper, I think. This was measuring neutron pulses using an activation technique. And I came in on Monday, set up the apparatus, and the technique worked. And I could use that to actually solve a mystery which has existed in the field for some time. 2 existing techniques gave completely different answers. And my technique came in, it's a much neater technique, and it agreed with one of them, so the other one was discarded. It was a great feeling to achieve something like that. It's almost a eureka moment, you know, when I discovered that the sodium iodide could be activated by neutrons. Published a paper on it, and it's great. It's a great feeling to do a bit of pure science. There's no project plan at the time. They hadn't been brought in. They were brought in later by wretched quality managers. I was one of them.
I don't think any university, certainly in the radiation area, I don't think any university could compete with us on equipment, facilities, etc.
No.
Certainly in the neutron area, it's the only neutron lab in Britain, and there's only 2 others or 3 others in the world.
Yes. Being at NPL was an amazing advantage because there was somebody who was an expert in all the measurements that you required yourself.
Yes, that's right.
I mean, I didn't have any problems doing mass measurements. I didn't have any problems doing time measurements.
No. We had the experts here.
And the expert time was piped round the site. You know, you had frequencies
no,
piped round this.
In those days, I'm not sure it's now, we had the computing expert as well.
Yes,
you could actually go and get people to help you do programming machines, etc.
When we measured radium, we measured ionization current. Ionizations, and the ionization chamber was sort of at the bottom of the chain of measurement instruments. But it had one advantage. You could compare any other standard with a radium standard, for example. And this told you whether you, when you remeasured your standard, whether you got a similar value, a value that was comparable to what you had last time, which is quite important when your half-life was only about 2 or 3 hours. And what happened in the end, these ionisation measurements became so crucial that we persuaded BIPM to set up an ionisation chamber. And now almost all the standards in the world are actually compared at BIPM via this ionisation chamber, using things that we actually used, well, similar principle to what we used when radium was first measured. It's quite full circle. Yeah. What I really enjoyed was the fact that we got to a situation where we had equipment that was so reliable, that we had methods of collecting and analysing results which are so reliable, you could actually concentrate on the science. And if you thought of an idea, you could try it.
Right, yeah. For the first 20 or 30 years I was at NPL, I thought it was excellent. I thoroughly enjoyed my time here.